All right, picture this for a second. What if your AI agent wasn't just, spitting out code snippets in a chat window, but was actually reaching right into your CI/CD pipeline, actively debugging failures, and fixing bugs directly inside your repository? Sounds like magic, right? Well, it's actually the power of agentic workflows operating straight on your code, and it is absolutely changing the game for software development.
Welcome to the Explainer. Today, we're demystifying the Model Context Protocol, or MCP for short. We've got a dual journey ahead of us. First, we'll look at how to get some incredibly fast wins using GitHub's hosted server. Then we'll flip the script entirely and dig into the nitty-gritty of building your very own custom MCP tools. Here's the roadmap for today. We'll start with the sheer power of GitHub MCP, then connect it to Claude Code and talk about designing agent-centric workflows. After that, we'll get our hands dirty building custom MCP servers, and finally wrap it all up with some absolute must-know implementation best practices.
All right, Section 1, the power of GitHub MCP, specifically looking at hosted versus local infrastructure.
So the contrast between the old way of doing things and this new approach is just night and day. Running an open-source MCP server locally? Sure, it works, but man, it carries some heavy hidden costs. You're stuck maintaining Docker images, manually rotating personal access tokens, and you're completely limited to localhost. But then you look at GitHub's hosted MCP endpoint, you literally just point your IDE to their API, do a quick OAuth login, and boom, GitHub handles the entire shebang. Auto upgrades, scope management, and it's reachable from any IDE. Because let's be real, the absolute best infrastructure is the infrastructure you don't have to manage it yourself.
And right out of the box with that hosted endpoint, you get this massive toolkit. You get repository intelligence, meaning you can search code without dealing with local clones. You get issue and pull request automation to triage and review. You get full CI/CD visibility to instantly fetch logs, plus security insights that surface those pesky depend-about alerts. Oh, and it has fine-grained controls. If you're demoing to stakeholders or just poking around a sensitive environment, you can flip the server into a strict read-only mode for total peace of mind.
To put that into perspective, let's look at what this can automate in literal seconds. Imagine just typing a prompt like, add a code owner's file for the backend team and then open a draft PR. The agent just handles it. No manual file creation, zero local cloning. Or say, hey, why did that release.yml job fail last night? It instantly pulls the logs and analyzes the stack trace for you. You can even tell it to triage critical depend-about alerts and create targeted issues. It's like having a senior developer instantly running chores for you.
Moving right along to Section 2, connecting to Claude Code. And this is a super quick 3-step setup. Honestly, the best part is how ridiculously simple this is to configure. Step 1, you just pop open your Claude settings JSON file, which is usually sitting right in your home directory. Step 2, under the MCP server section, you drop in the GitHub protocol block using the standard npx command for input and output. And step 3, paste in your GitHub personal access token. Give your environment a quick restart, and suddenly you have your entire GitHub context fully integrated directly inside Claude Code. It's that easy. Now, a quick pro tip to keep your workflow actually efficient. Here's a golden rule to live by. Use MCP inside Claude for remote operations. I'm talking about creating issues, opening PRs, managing the repo itself. But for your local version control, like your local commits, branch switches, and merges, stick to your trusty terminal and the standard Git CLI. Mixing those two approaches gives you basically the ultimate developer experience.
Okay, Section 3, designing agent-centric workflows, or what I like to call the power tool analogy. So if you decide to take the leap and build your own custom MCP integrations, you absolutely have to understand agent-centric design. This is all about building workflow-oriented tools that take the heavy lifting off the AI's plate. Think of it like this. You wouldn't hand a carpenter a random pile of loose gears, a motor, and some wire and say, hey, build me a house. No, you hand them a fully assembled power drill. It's the same here. Don't give your AI raw, unorganized endpoints. Give it an automated, streamlined power tool.
Let's look at how that actually plays out in practice. If you take the old API-centric approach, you're basically wrapping every single tiny endpoint. Get user, get ticket, get repo. What happens? Your token usage goes through the roof, and the AI is sitting there wasting time making 10 or more separate tool calls just to answer one question. But if you use the agent-centric approach, you consolidate all that into one single tool, like Get User Context. Suddenly, the AI has everything it needs in maybe 1 or 2 highly efficient calls. Total game changer.
Which brings us to Section 4, building custom MCP servers using Node and TypeScript. Now, if we want to keep this ecosystem clean, we have to stick to some pretty strict naming conventions. Your server needs to follow a specific format, the service name -MCP server, so something like GitHub-MCP server. For your tools, use Snakecase, but you absolutely must include the service context to avoid clashes. Name it GitHub_create_issue, not just create issue. And on the architecture side, always initialize things using the MCP server class provided right in the SDK.
And guys, this is a massive point if you're working with the TypeScript SDK. You must always use the modern APIs, specifically server.register_tool. Please never use the old deprecated APIs or manual handlers. Relying on the modern register methods means you're going to get proper type safety and automatic schema handling right out of the box, which saves so many headaches later on.
To make sure your build is rock solid, here is your rapid-fire TypeScript checklist. First, enable strict mode in your TS config, non-negotiable. Second, you absolutely must use Zod for runtime input validation. And don't just define the shapes, slap a .strict on those Zod schemas so the AI can't just hallucinate extra fields that aren't supported. Finally, explicitly provide your tool descriptions. JSDO comments don't magically get extracted, so you have to manually write out clear titles, descriptions, and schemas.
All right, final stretch. Section 5, Implementation Best Practices. We're talking scaling, guardrails, and testing.
When you're building, you'll often have to choose between creating a tool or a resource. Here's the rule of thumb. Use tools for complex operations, anything with side effects or heavy business logic. But if you just have simple data access like a static template or basic URI-based data, expose that as a resource. It gives the AI super efficient read-only access without bogging things down with a full tool execution.
Now, if you take one thing away from this explainer, let it be this number, 99%. By implementing that agent-centric design we talked about earlier and really optimizing your workflows, service developers are seeing up to a 99% reduction in token usage. Seriously, condensing multiple API calls into one unified tool dropped a pipeline monitor from over 37,000 tokens down to just 421 tokens per check. I mean, that is literally massive for both your speed and your wallet.
But to pull that off safely, you need to put some essential guardrails in place. AI agents can get overwhelmed really quickly by massive data payloads. So you have to implement pagination for lists, you need to add character limit constants, and gracefully truncate responses if the data gets way too large. And always provide clear, actionable error messages. If something fails, the agent needs to know exactly why so it can correct its own mistake without needing you to jump in.
Which leads us to a core philosophy for any developer. Never build what you haven't tested. When it comes to MCP, this means a strict multi-phase approach. Validate your API clients first. Then test your MCP server tools locally, just to verify those JSON responses are absolutely perfect. Only after all of that is working flawlessly on your local machine should you even think about connecting it to your Claude desktop or any other AI interface.
Well, we have covered a lot of ground today. From the completely zero-friction setup of the hosted GitHub MCP, all the way down to the strict TypeScript validation you need for building your own tools. This ecosystem is moving incredibly fast, and the future is clearly agents seamlessly collaborating with other agents. So I'll leave you with this one question. What is the very first workflow you're going to automate with MCP? Go dive into the docs, authenticate your IDE, and let's find out. Thanks so much for joining me for this explainer.